Hello everybody, and welcome back to another episode of Phys with Liv. Today we're looking at the Entero-gastric Reflex, which looks at how the duodenum responds to food that enters. As a little map key, we have our duodenum here, our liver, our bile duct, our stomach, and our pancreas. And then in pink we have our blood vessels. So the first step to our enterogastric reflex is we have food or chyme that's really acidic, meaning it has a really low pH, and it flows, it moves, it's getting digested, and it enters the duodenum. Amazing. So in response to food in the duodenum, we have a few things that happen here. We have an increase in stretch, we have a decrease in pH, and we have an increase in osmolarity. So, in response to these things, stretch causes the duodenum smooth muscle to contract. A decrease in pH and an increase in osmolality talks to this duodenal gland. And this duodenal gland thus produces bicarbonate. And this is a buffering solution that helps lower pH. So also within this, we have enteroendocrine cells. And these cells are going to release a couple things. So we're going to have secretin, and we're going to have CCK. Now, both of these enzymes or proteins are going to be released from the duodenum, but they're going to travel. So our CCK and our secretin are going to enter the bloodstream. Now both of them are going to travel. Just gonna go, since they're from the enteroendocrine cells. That means they have an endocrine-like effect. So that means they are flowing through the blood, just everywhere. Along with the secretin, just going everywhere. Amazing, flowing up, flowing up. Okay, so our first stop is at I wrote bile duct. That is incorrect. That is a gallbladder, so let's just forget I wrote that. Amazing. So, at our gallbladder, we have bile that's been stored. It was produced in the liver and is here now. Our CCK from the blood is going to signal to the gallbladder that it needs to release bile. So this bile is then going to travel down into our duodenum. And the bile helps emulsify fat, so it helps break it down into smaller parts. And fats they split, they go to chylomicrons and micelles, so it's easier to absorb. Amazing. The next stop we have is, we could say the next stop's the stomach. Amazing. Both CCK and secretin are working here at the stomach, and they both enter. We have CCK signaling, and we have secretin signaling, and they are telling the body or the stomach that they need to slow their roll. the duodenum is hard at work and it just needs some time to do its thing. So this means that the stomach needs to decrease its contractions and decrease its juices, or its digestive enzymes. So we have decrease in contractions and decrease juices. And as a reminder, these contractions are smooth muscle. It's not a blaring fact, but it's just good to remember. Okay, so we've got bile going in from the gallbladder. We've got decreased contractions and juices in the stomach. Then our next stop is the pancreas. Now this pancreas, it means just all body, all life, all whatever. It is the mega endocrine gland. It just can do everything, pretty much. So first, our CCK signals to the pancreas. And the CCK is telling the pancreas that it needs to release bicarbonate enzymes. It's like, hey bro, let's see those bicarbs. The duodenum needs ya. So the CCK tells the pancreas, I'm just going to lower this. Actually, I'm going to bring it up. Release bicarb enzymes. Amazing. So then these, we'll get back to those. The secretin also signals to the pancreas. We're going to say he comes in here. The secretin. The secretin is telling the pancreas, hey, guess what? We need some bicarb. So it's telling it to make bicarbonate. Awesome. So in our pancreas, we have CCK and secretin telling the pancreas, hey, we need some bicarbonate enzymes and we need some bicarb. Amazing. And both of these are going to travel. They have their own tube, the pancreatic duct, and they are going to enter the duodenum. And these help with neutralizing the acidity of the duodenum, and they help digest other items. Amazing. That's our entero-gastric reflex. So as a refresher, we have our acidic chyme. It's traveling through the stomach, past the pyloric sphincter, into the duodenum. Duodenum increases in stretch, decreases in pH, so it gets more acidic, and it increases in its osmolarity. Stretch says contract. Start that mechanical digestion. These two chemical factors signal to the duodenal gland to make bicarbonate. We also have signals for our enteroendocrine cells that's connecting our hormones, our endocrine system, saying, hey, we need some CCK, we need some secretin, we need to send the messenger. So our messenger enters the bloodstream, and it makes 3 major stops to the bile in the gallbladder, to the stomach to decrease contractions in its juices, and also the pancreas to increase that bicarb. Amazing. Here is our system, and have a fabulous day.